Welcome to The Explainer. Today, we are diving into one of the most incredible scientific tools ever invented. Seriously, it's a technique that lets us basically listen to the whispers of the distant past. We're talking about radiocarbon dating and how it completely cracked the code of ancient history. So, to really see this in action, let's start with a famous historical puzzle, the Dead Sea Scrolls. I mean, when they were found back in 1947, how could anyone be sure they weren't just some really clever fake from the Middle Ages? Well, the answer, it turns out, is hidden in this amazing natural clock that's ticking away, silently, inside every single living thing on this planet. Okay, so to get how this carbon clock works, you kind of have to meet the guy who came up with it, an American chemist named Willard Libby. Back in the late 1940s, he had this idea that was just brilliantly simple, and it was all based on a slightly unstable radioactive version of carbon. All right, so how does this clock even get started? Well, it all begins way up in the atmosphere. Cosmic rays from space create this special radioactive type of carbon called carbon-14. This C14 mixes into the air, plants absorb it, and then it works its way up the food chain. Now, as long as an organism is alive, a tree, a person, an animal, its C14 level is pretty much the same as the atmosphere's. But the moment it dies, that stops. No more C14 comes in. And that's it. That's the moment the clock starts ticking. And this clock? It ticks with unbelievable precision. See, once an organism dies, its carbon-14 starts to decay. And we know exactly how fast. Every 5,730 years, that's what we call its half-life. Exactly half of the C14 that was there is gone. So if you can measure how much is left in a sample, you can work backwards and calculate almost exactly how long ago it died. It's pretty amazing. So Libby tested his new theory on things where we already knew the age, like wood from ancient Egyptian tombs. And the dates he got back were just astonishingly close to the historical records. It was a huge success, and it ended up earning him the Nobel Prize. The carbon clock, it seemed, was absolutely perfect. But as more and more labs started using this method, they began to notice some strange things, little discrepancies. It turned out Libby's incredible clock wasn't quite as perfect as everyone thought. Yeah, this seemingly flawless idea was about to hit a major plot twist. So here was the problem. The whole method, the entire idea, was built on one single critical assumption: that the amount of carbon-14 in the atmosphere has always been the same. But here's the thing, it hasn't, not even close. We now know it's gone up and down over time, which means the baseline for the clock was always shifting. It was like trying to tell time when the length of a second kept changing. So what was making this clock so wobbly? Well, a few different things. For one, you had natural cycles in cosmic rays that changed how much C14 was being made over thousands of years. Then came the Industrial Revolution. Humans started burning massive amounts of old fossil fuels which have zero C14, and that diluted the C14 in the air. That's called the Suez effect. And then came the most dramatic change of all, something called the bomb pulse. All those above-ground nuclear weapons tests in the 50s and 60s pumped so much radiation into the air that by the mid-1960s, the amount of C14 in the atmosphere had almost doubled. I mean, look at that spike. This bomb pulse was this huge, undeniable signal that made one thing painfully clear. If you wanted to get accurate dates, you needed a way to correct for all these wild swings. So that became the million-dollar question. How in the world do you fix a wobbly clock? You can't just hop in a time machine and go measure the atmosphere from 5,000 years ago, right? What you need is an archive, some kind of natural record that perfectly captured the C14 level for every single year, stretching way, way back into history. And incredibly, that exact archive already existed. Scientists found the solution locked away inside ancient trees. Think about it. Every year a tree grows, it forms a new ring. And that ring absorbs carbon directly from the atmosphere, creating a perfect little snapshot, a time capsule, of the C14 level for that specific year. This led to this massive scientific effort. By taking core samples from living trees, then finding older wood from, say, historic buildings, and even older wood from archaeological digs, scientists could match the overlapping ring patterns. They literally pieced them together like a giant jigsaw puzzle, building this incredible, unbroken, year-by-year master calendar of tree rings, stretching back nearly 14,000 years. So by then, taking each individual ring in that master sequence and radiocarbon dating it, scientists created the ultimate fix, a calibration curve. You can think of it like a master correction chart or a translation dictionary. You take the raw radiocarbon age from your sample, you find it on the curve, and the curve tells you what that translates to in a precise calendar date. This was the instruction manual the wobbly clock so desperately needed to finally tell perfect time. And with this newly calibrated, incredibly precise tool in hand, our whole understanding of the human past was about to be completely rewritten. And I'm not exaggerating. This wasn't just a small improvement. This was a revolution. The anthropologist R.E. Taylor put it perfectly. He said that C14 data made a truly world prehistory possible for the first time. It created this universal timescale that could connect every corner of the globe. I mean, think about what this meant. Before this, dating was all relative and local. But now archaeologists could confidently date the end of the last ice age. They could compare the timeline of a culture in Europe with one in the Americas. And it shattered all these old theories that big ideas like agriculture or building monuments started in one place and just spread out. The new corrected dates proved these things were often popping up independently all over the world. It was like a second radiocarbon revolution, changing not just when things happened, but how we understood our own history. Which brings us right back to our original question about the Dead Sea Scrolls. Thanks to this newly calibrated carbon clock, the linen wrappings from the scrolls were tested, and the results? They were conclusive. The Great Isaiah Scroll, for example, was dated to between 355 and 45 BC. They were not medieval fakes. They were the real deal, authentic texts from a truly pivotal moment in human history. So, from a brilliant, simple idea in a lab to this globe-spanning scientific tool, radiocarbon dating has literally given us a timeline for our shared human story. And it keeps refining that story with every new sample that gets tested. It really just leaves you wondering, what long-lost secret from our past is it going to uncover next?